Okay, so now that you've tried your hand at writing equivalent expressions, or at least identifying them, we're going to talk about a little bit of a different scenario, but it should come a little bit easier to you this time now that you've had some experience. So here's a different scenario. We have -2 and -7. So -2 plus -7. So this could be represented by maybe going to Kroger and spending $2. I'm sorry, going to Dollar Tree, spending $2. And then spending $7 at Kroger. So this is a situation where you have two debts, a debt of $2 and a debt of $7. This can be represented on the number line by saying we have a debt of $2 by going down 2 and also going down 7. Sorry. This is actually worth pointing out. What I did is I went down 2 and then I went down to 7. The problem is that I didn't go down 7 more, so I didn't spend $7 more. What I did is I went 1, 2, 3, 4, 5 down, which is not what our problem says to do. So let's correct that. We need to go down 7. So 1, go down 1, 2, 3, 4, 5, 6, 7, and you can count that out by doing little jumps. This is just a shortcut to draw the arrow. So we have down 2, down 7, and that will land us at a -9. It's having a debt of $2 and a debt of $7. That is a debt of 9 altogether. You can represent that as well by having 2 negatives, 1, 2, 3, 4, 5, 6, 7 negatives. And what you end up with on the board is nothing to cancel out. You don't have any positives to cancel out those negatives. So in total, you have 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives. This is using the commutative property. We can rewrite that. So we can take -2 plus -7, and we can switch the order to put the -7 first. And now we have -7 plus -2. I want to apologize because this is an error. I should have put parentheses here. So this is what we're talking about when I say the plus and the minus, or the plus and the negative together like that. Makes it a little bit messy or harder to look at. So we can put parentheses. You could put parentheses here too if you wanted, but it's just not going to be as commonly seen. So those parentheses should be there. This is another example of this is you could spend $7 at the store and then spend $2 more. So the only difference in our number line situation here is what we're going to change is the fact that first we're going to go down $7 and then we're going to go down 2 more. So we're going to go down 7 and then down 2, and that will again land us at -$9. And our third example is even murkier. Like it doesn't have much of a difference in the ring and the way it sounds. Like you spend $2 and then you spend $7 more. So either way in this situation, we're going down $2 and we're going down $7. So you can look at that on the number line, like going down 2 and then spending $7 more. We know spending 7 is going down, down 7. No matter what we do, we end up at -9 as our answer. One thing you'll see, if you remember from our earlier examples, we can take a subtraction problem like 3 minus 5 and rewrite that as an addition problem, 3 plus -5. What we have here is the reverse of that. We have an addition problem that we rewrote as a subtraction problem. So I'm going to write that down here. 3 minus 5 is the same as 3 plus -5. Here we have an addition problem. -2 plus -7 is the same as -2 minus 7. Oh, Notability auto-corrected that. -2 minus 7. So Negative 2 plus negative 7 is the same as negative 2 and go down 7 more. We will hopefully get to a point where you won't really be worried too much about what's going on in the middle. You just need to know what these numbers are. This is a negative, and this is a negative. Negative 2 and negative 7, or negative 2 and going down 7. Either way, same thing, ends you with 9 negatives. So I know that was a lot. Like I said, let's go through a couple more examples, and that should make a little more sense. So let's talk about our first example, or our first example on this slide. Negative 1 and negative 10, or negative 1 plus a negative 10. What we're saying is the football player has 2 plays. One of them is a loss of a yard, and the other one is a loss of 10 yards. We could write that on our vertical number line as 0. That's our loss of 1 yard. And then we need to go down 10 more. So we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and shoot, we are out of space. This here is a negative 10. We're going to have to go down 1 below that. We know below negative 10 is negative 11. And, okay, sorry about that. All right, so we end up back at down at negative 11. This could also be written as negative 1 and 10 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we can count those 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 negatives because there were no positives to cancel that out. This can be rewritten using the commutative property. We can switch these guys around. So we can, instead of the negative 1 coming first, we can put the negative 10 first. And again, I have to apologize. I think it'll probably be the same on the next slide. This plus and minus shouldn't be right next to each other without a parentheses to kind of clean it up. So if we put the negative 10 first, negative 1 comes second, and we put parentheses around to keep it a little cleaner. All right, and that can be represented by the football player having a loss of 10 yards and then losing 1 more yard. So we can go from 0 down 10 yards. So that's a loss of 10. And then losing 1 more yard lands us at negative 11. And our last example is writing this problem, honestly, a little bit simpler than what we're seeing here in our first 2 examples. They're written as addition problems. We can also write that as a subtraction problem. It's the same as the football player having a loss of a yard and then losing 10 yards. So losing 10 yards means subtracting 10 yards or going down 10 yards. It also means negative 10. We can write that either as a subtraction problem like this, or as an addition problem. We just know that the 2 things we're adding are both negative. So we have negative 10 and negative 1. Or we can think of it like negative 1 going down 10. Either way, if we show this on the number line, showing this one on the number line, we're going down 1. And then going down 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In all cases, we end up at negative 11 either way. All right, and one more example before you practice on your own or before you try your hand at this. We have a negative 3 plus a negative 8. Negative 3 and a negative 8. This is like losing 3 points and losing 8 points. So this is a loss of 3 and a loss of 8. We can write that as a loss of 3 and a loss of 8. That's 1, 2, 3, 4, 7, 8. And then once we have everything on the board, we know that there are no positives to cancel out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we end up with negative 11 again, like our previous problem. We can re-say this or rephrase this by saying we lose 8 points and we also lose 3 points. So there's a loss of 8 and a loss of 3. This can be written on the number line like a loss of 8 down 8 and a loss of 3, so a loss of 3 more points. We land at negative 11 still. And our third representation, the other way we can write this, so we've written it as an addition problem. We can also write this as a subtraction problem. This is like having negative 3 points and then losing 8 points. Well, we represent losing 8 points like going down 8 or minus 8. So we can start at negative, so we'll start at 0. And I'm actually going to come over to this number line because this one has the 11 on it. So we're going to start at 0 and go down. This is like starting at negative 3 basically. And then losing 8. We know that means 1, 2, 3, 4, 5, 6, 7, 8. We are going down 8 points. Once again, that lands us at negative 11 points. So like I said, we can write this as an addition problem. The addition, the two things we're adding is a loss of 3 and a loss of 8. Or we can look at it like a real world problem where we have already a loss of 3 and then we go down 8 points. Either way, we're ending up with the same answer.